when we want to build an application that requires real-time streaming of data that is highly distributed and scalable, that is when a tool like Apache Kafka becomes very useful. So companies such as Adidas, Axios, and Airbnb utilize it. So at a very high level overview, whenever we are dealing with an exorbitant amount of data and we want to consume the data or represent the data, or we want to process that data across multiple different devices, then Apache Kafka becomes very apparent. So in this video, let us lay the foundation of the very basic concepts of Apache Kafka, and I'll also be showing you a very small application utilizing it so that whatever we've learned is solidified. Now, to understand what Apache Kafka is and what problems it solves, we'll have to talk a little bit about its architecture. So at the basis, Apache Kafka is just a cluster of different servers. So you can see this box right here, this big box which encompasses all these brokers is the cluster, and these box inside that big box, which is called broker 1, 2 and 3, are individual servers. So this is why Apache Kafka is very highly scalable and distributed. You can just keep adding servers according to your need, and that server will solve a definite problem. Now, each of these brokers are further divided into topics. Now, each broker can have n number of topics that handle a specific type of data. So let's consider a case of collecting data from various different countries. So let's say broker 1 handles the data of America, broker 2 handles the data of Cuba, broker 3 handles the data of, let's say, China. So now these brokers can be further divided into topics. So let's say this broker that handles the data of America, we can further divide it with topic ABC that handles data of specific states. So now topic A might handle the data of California, topic B can handle the data of New York, topic C can handle the data of Texas. So thereby we have a more distributed system that handles data of specific states, making it more easier for us to work with that server or data. Now, just to make it more easier for us, let me just zoom this. So now that we have zoomed into a particular topic, we can visualize how a topic looks inside. So a topic now can be further segregated into partitions. So we could have n number of partitions. Now to visualize all this, we could take the example which was previously established, which was the example of how this broker 1 handles the data of America, and these particular topics handles the data of various different states of America. So if I remember correctly, topic C handles the data of Texas. So now we could further divide the data of Texas into various different areas of Texas. So if, let's say, partition 1 handles the data of Austin, partition 2 handles the data of Houston. Now if there is a new use case where we need to represent the data of, let's say, Dallas, we could just add a partition to this particular topic, and that would handle all the data of that particular area of Texas. Now that we can visualize this, we can see how Apache Kafka allows us to build a very highly distributed and scalable system. Now that we have a basic understanding of the architecture of Kafka, let us talk about how to actually add and read those data from a particular topic. So this is when a producer and a consumer comes into play. So just from the way it sounds, producer is something that produces or adds data to a particular topic, and consumer are something that consumes or reads that data from a particular topic. Like you can have n number of producers that subscribes to a particular topic. So producer 1 probably can subscribe to topic X, Y or Z, and the same way consumer 1 can subscribe to topic X, Y or Z. So now a given producer can add data to a particular partition, or it could produce or add data to n number of partitions. And same way, a consumer can read from a particular partition, or it could read from n number of partitions. But here there's a catch. So let's just assume that there's only one producer and one consumer, and this producer adds data to partition 1, 2 and 3, and this consumer reads reads the data from partition 1, 2 and 3. Now what would happen if there is another consumer which is added to this architecture? So now what would happen is partition 1 or 2 could be read by this consumer, and partition 3 could be read by this consumer. It is never definitive. It could be that 1 and 3 is read by this consumer and 2 is read by this consumer. So to solve this problem now, a new concept comes into play, which is called consumer groups. Now let's just assume that we have two groups in this architecture. So group 1 consists of two consumers and group 2 consists of just one consumer. So in the case of group 1, perhaps partition 1 would be consumed by this consumer. Perhaps partition 3 and 2 would be consumed by this consumer. But in the case of group 2, partition 1 would be consumed by this consumer. Partition 2 would also be consumed by this consumer, and partition 3 would also be consumed by this consumer. So that is probably it for all the basic concepts that is required. But some of you all may be hesitant of working with Kafka after me talking so much about its internals. But the thing is, there is something called Zookeeper, which is at the heart of Kafka, that handles internally all of these segregations and handling all the consumers, producers, servers, etc. So Zookeeper, you'll be seeing it shortly. Zookeeper is just something that Kafka needs in order to handle all of this internally. I've got VS Code running here and there's nothing much going on, so I'll just explain what we have. I have a package.json file, so you just npm init-y and you should get a package.json. And as far as the dependency is concerned, I've got two packages, which is IP and Kafka.js, which is both required to do this. And then probably the more important one is this Docker Compose file. So if you all are not familiar with what Docker is, I've already created a video on Docker, so it just goes over the basics of Docker and Docker Compose. You all just can watch that. I'll link it in the cards. And yeah, so this file essentially says to create a Zookeeper service, which gets it from this image, and as well as a Kafka, which uses this image. And then the only change which you would need to make is this part right here, your IP address, and this you can get it from your Wi-Fi settings. So just go to Wi-Fi settings, and if you go to details, and you can just copy this IP address right here, or else alternatively you could also go right here and just say ifconfig en0, and this should be your IP address. You could just take that and paste it right here. So once that's done, you could just run the service by saying docker compose up, and we want it in detached mode, so -d, and that should start our service. Once all of your services is created and running, initially it might take some time, but after it's done, you could use another tool called Docker Desktop. So you can install this via the internet, and you could go to this containers tab, and you can see we have a multi-container instance running right here. So that's how you can check it. I'll just close this. So once that's done, I'll just close all of this. So what we'll do is, now let's create a source directory. In there we'll instantiate the client, so Kafka client to be precise, client.js. Now let's import it. So import Kafka from Kafka.js, and we'll also import our IP from IP. And if you see in package.json, this is of type module, that's why I'm using those imports. So once that's done, let us create the host. So this is just a constant. So we've created a host, either it comes from the env file, which is not there, or from ip.address. So this package handles that, so it'll just take out the IP address from the network and you'll have it in this string right here, host. So next is we'll instantiate it, so const Kafka client. So inside the constructor will have to give it an ID. This can literally be whatever you want it to be. And for the brokers, now as I said earlier, broker is just a single instance of Kafka. So we give it the host, the IP address, and 1992. We'll save that and we are done with that. Now we'll also have to export this. So export default Kafka client. It's fine. So now next up is to create another file called admin.js. The way you instruct Kafka on how to create topics, the number of partitions, is through admin. So this file will handle all of that. So let's start off by importing Kafka client from here. So once that's done, let us create a function called init, and inside this we'll create an admin which comes from Kafka client.admin, and then what we can do is we can connect to it. So await. So once we've connected to the admin, let us create the topic. So the way you do is through admin.create topics. You mention the topics, you can create multiple topics. So in our case, we have only one topic called Tabish's topic, and it will have 2 partitions. So once that's done, I can, let me just say console log, and we'll also disconnect the admin. Okay, so through this console logs, we'll know that the topic was created and the admin was disconnected. Let me save this. Now let us create another file called consumer.js. I don't think I can run the function. Yeah. So in here, I'll also run the function when this file is executed. Now, as for the consumer.js, again, we'll import from Kafka client. This client is responsible for creating consumers, producers, etc. I'll call this function run. And in here, I'll say const consumer. Now inside here, you'll have to mention which consumer, which group this consumer belongs to. So I'll just say group ID, let's just say test group, and then we'll have to connect our consumer. So let's connect to it. Again, this should be an async function. So now we'll have to tell this consumer where to subscribe to, which topic to subscribe to. So that's what I'll do now. Okay, so this line just mentions which topic to subscribe to, and it should subscribe to it from the beginning. That's it. Now all we have to do is run this consumer. So I say await consumer dot run, and this will be async function which is for each message. So each message it gets, the function it has to run with. So async, and I'll say topic partition. So this function gives us topic, the topic which is subscribed to, the partition, and the message. So I can just say, for the sake of demonstration purposes, I'll just console log it out in the terminal itself. So this is what I'll log: the topic, the partition, the key which will be sent, and the message value. I'll save that as well. Now lastly, I'll also create another file, which is our last file, called producer.js. I'll just copy this, and I won't forget to run this function. I'll save that. I can paste this right here. I can also say run. Let's start changing this. So this is producer, and this will be Kafka client dot producer, and inside this we'll also have to mention an additional property called create partitioner. Again, now if you don't do this, you'll be getting some warnings saying legacy, partitioner, etc. So to avoid that, I'm just mentioning the partition type. So once that's done, we'll have to connect our producer again. So producer dot connect, and now it'll be producer dot send. Which topic should we send data to? So that is producer dot send the topic name, which is Tabish's topic, and this is not required for this case. In this case, it will be messages. So again, messages is, so it will be an object. So I'll say which partition to send the data to. So partition 0, and the key will be, let's just say something random. So let's say user 1 says something, and let me just say value, and I'll say some message by user 2. That's fine. So now what I'll do is, we don't need this part. I'll say await producer dot disconnect. So that's about it. Okay, so yeah, so that's it. So we have a admin that creates the topic, a consumer that listens to a topic, and a producer that sends off some data to a particular topic. So now let's demonstrate how all of this works. So here I've got a terminal running. So this is called Warp. It's a tool, so it gives some suggestions and all. It's just like terminal, but it's just a superset of it. It would work the same way as how it would work in terminal. So for now, what we'll do is, first let's execute our admin.js file. So this will create those topics for us. So let me just say node admin, it should be in source admin.js file, and I got an error saying error module not found. Okay, so let me go back to here. I think this is because of .js. So once I've done that, let me run that again, and you can see topic is created, admin is disconnected. So that's working. So let me just correct that as well here as well. So .js. Okay, so I've fixed those problems as well. Now what we'll do is, let me create another instance of terminal. So this will be the consumer. So let me say node source consumer.js. Now let's wait for some time, and that should start up the consumer. Okay, so I think it started. Let me clear all this. So this will be the producer now. So let me say node producer.js, and if you remember, in the producer.js, key is user1, and this is the value we are sending it to partition 0. So node, this should be in source, and if I hit, I'm getting those console logs right here, and this is in partition 0. Now what happens if I change to partition 1? Now if I execute this again, you can see whatever we are producing, since there's only one consumer, both the producers are producing to the same consumer. So now what I'll do is, I'll create another consumer here. So this is another consumer. Let me go here. Cool. So now what I'll do is, I'll say node source consumer.js. So now I'm adding another consumer to this group. So if I go back here, this is the group, test group. I'm adding another consumer. So yeah, so from what we learned from the concept part, if I produce a data now, it should go to only one of these consumers. Okay, now let me do this. You can see partition 1's data is here, partition 2 did not get anything. Let me show it to you again. Let me actually, yeah, that's fine. I've zoomed in as well. So now if I produce it, you can see partition 1's data is here. Now if I say go back here and say 0, partition 0, if I hit it, it should go here. So now this doesn't get any data, this gets any data. So now let's try producing data to both of those partitions. So now here 0, let me say 1, let me say here, let me do this, let me do that. So now what we're doing is we are producing data to both of those consumers, one that is listening to partition 0 and one that is listening to partition 1. So now if I run this, the data should go to both of these. Yeah, you can see both of these got the data. So that's basically it for how consumers, producers and all work together. I know this is a very simple use case for this, but this has laid down the fundamentals of using Kafka, and in the upcoming videos we'll try to build more complex application with it. That's all. Thanks for watching.